Question 2.4. We now want to determine the number of terms in the sequence that is exactly divisible by 5. So I think what we could do is we could rewrite a new sequence with all the numbers that are divisible by 5. So the first number is already divisible by 5, which is 5. So the next number divisible by 5, we can figure that out. So remember, my common difference is negative 4. So that becomes 1. That becomes negative 3. The next term is negative 7. Minus 4, that gives you negative 11. Minus 4, that gives you negative 15. So this could be the second number that's divisible by 5. So your second term, or your second term in the sequence that's divisible by 5 is minus 15. And so on and so forth. There will be quite a few more of them. And then to figure out the last term, we can actually work backwards from negative 4187. But this time, we can actually add 4. If I go forward, that's going to become negative 4183. That's not divisible by 5. You can add 4 again until you come by the first number that is divisible by 5, and that's going to become negative 4175. So this is the last negative term that is divisible by 5. So now we formed a new sequence, and all I have to do is figure out the number of terms. So I could use my Tn formula for an arithmetic pattern, which is Tn is equal to a plus n minus 1 times d. Tn is the last term that's divisible by 5, which is negative 4175. A is the first term, which is 5. N we are trying to calculate. And now remember, your common difference is T2 minus T1, which is negative 15 minus 5. That's going to become negative 20. So our common difference is now different to what it was in the original pattern. And all I have to do here is to solve for n. If I distribute the negative 20 inside the bracket, we're going to get negative 20n plus 20 plus 5 is equal to negative 4175. And all I have to do is I have to solve for n. So negative 20n is equal to 20 plus 5 is 25. If I move that across, we're going to get negative 4175 minus 25. That becomes negative 4200. And if I divide both sides by negative 20, I will get the number of terms that's divisible by 5. And the answer comes out to be 210. So 210 terms of this pattern are divisible by 5.